Bonding models. By the end of this topic, you should be able to understand and explain the difference between covalent, ionic and metallic bonding, and to be able to give examples for each of the bonding types, covalent, ionic and metallic. The following bonding models shall show how the atoms are held together. They do not explain the molecule structure, which is how the atoms are arranged in space. We shall begin with covalent bonding. This is a bond that is formed between two nonmetals. An example of this is water. Each of the hydrogens have one electron in their outer shell and the oxygen has 6. In order to form a full outer shell, the hydrogen and oxygen atoms share one electron between them, forming a full outer shell for each of them by the octet rule. And thus we can see that a covalent bond is a shared pair of electrons between two atoms, and the molecule does not contain any charged ions. This then forms two single bonds between each of the hydrogens and the oxygen. The second example of covalent bonding is carbon dioxide. Each of the oxygens have 6 electrons in their outer shell, and carbon has 4 electrons in its outer shell. Each of the oxygens and the carbon share 2 electrons between them. This means they have 4 shared pairs of electrons between them. Oxygen shares 2 electrons with the carbon atom, and carbon shares 2 electrons back. This then forms 2 double bonds. Our last and final example of covalent bonding is silicon dioxide. Silicon has 4 electrons in its outer shell, and oxygen, as we have seen before, has 6 electrons in its outer shell. Now we would normally expect silicon dioxide to form 2 double bonds, just as seen in carbon dioxide. However, this does not occur. This is because silicon has a larger atomic radius than carbon, and so is less similar in size to oxygen. Due to this difference in size, silicon is unable to form 2 double bonds and instead forms 4 single bonds to 4 oxygens. Each silicon has a shared pair of electrons with 4 oxygens, and this creates a giant covalent structure as seen here. Each of the electrons in black are still available to form a shared pair of electrons with another oxygen atom, and so the giant covalent structure keeps growing. We shall discuss the structure of silicon dioxide later in more detail. This here only tells us how the atoms are bonded to each other, not how the atoms are arranged in space. Our second bonding model is ionic bonding. This is a bond between a metal and a non-metal. An example of this is sodium chloride. Sodium has 1 electron in its outer shell, and chlorine has 7 electrons in its outer shell. Chlorine is 1 short of having an outer shell electron count of 8, and sodium has 1 extra electron in its outer shell. So sodium transfers its 1 electron to chlorine, forming 2 ions, where the sodium is now positively charged and the chlorine is negatively charged. And so we can say that ionic bonding is a transfer of electrons from a metal to a non-metal. Last of all, we have metallic bonding, which is slightly different to covalent and ionic bonding. If a metal such as magnesium doesn't have a non-metal present, it is able to lose its own 2 electrons to form a full outer shell, and then forms a magnesium 2+ ions. These electrons are delocalized throughout the structure. So we can say that a metallic bond is the strong attraction between positively charged metal ions and delocalized electrons in the structure.